Swanson give his perspective and his credence to this inevitable shift to our transition to electric vehicles. And so with that, we're excited to welcome John Swanson, and please with me warmly welcome John Swanson to talk about that with us today. John, we're delighted to have you.
Thank you, Jimmy. It always embarrasses me when the introduction is longer than the talk, but so be it. If I can bring my presentation up here, the shape, and away we go. All right, this is going to be a diverse talk because there's a lot of issues that are present in this area, and I want to make sure we all have a common foundation. So we'll start out very lightly, and we'll dig into more issues as we go through. So with that, I appreciate everyone being here. I hope everything is working and stays working, and away we go. This is a Zoom presentation. There's a large audience, possibly. Everybody should be muted. I think that'll be fine. We are recording, and the copies of the PowerPoint and the Excel worksheet will be available to anyone who wants the same. I have an outline, which is always good. I won't go through it in detail because we'll see it as we go. Now, why an electric vehicle? First of all, they're really great. They're smooth and quiet. There's no transmission. You've got high torque and low speed. For example, I'll reference the Tesla Insane mode, where everything it's got is put into the wheels, and it's a 2.5 second, I believe, 0 to 60. Hold your hat. Also, they're very smooth riding, no engine vibration. They're quiet, perhaps too quiet, because some places we have artificial noise generators in the car just to warn the pedestrians that we're creeping up on them. And also, they're great handling because of the low center of gravity. And that's a positive and a negative because they have heavy batteries, and we'll get the heavy batteries in a moment. They are low maintenance because the powertrain is much, much simpler than it is for a gasoline-powered engines. And of course, last but not least, there's no emissions.
Excuse me, John.
We're
not able to see your presentation.
I can see it. Be technically inclined, help us out here.
Sure. Click the share screen button at the.
We probably wouldn't be looking at electric vehicles because there's enough carbon under the United States to last us for many, many years. Now, of course, the comment from MIT Technology Review, for example, this current month, for many buyers, they're simply too expensive, their range is too limited, and charging them isn't nearly as quick and convenient as refueling at the pump. So this is the headwind. They are not quite what we'd like them to be. Going into a little history, this is a Ford Fusion hybrid. This is a hybrid whose only function is to increase the range of the gas engine. You did not put electricity in this from the outside. It was all generated with gasoline. The mileage was typically about 42 miles per gallon, even with the regenerative effect of the electric vehicle. So it has small battery, regenerative braking, downhill energy storage, long total range because it got over 500 miles on the gasoline tank. No range anxieties because of the gas engine. There was some fairly nice logic as to how the battery and the engine work together. I won't go into that because it's past history. The next level is, this is my current car. This is a Toyota Prius Prime 2019. Now, the Ford Fusion I had for about 9 years. Battery was fine, didn't have to change the battery, but it had a mileage capability in that small battery of approximately 1 mile. This has a significantly larger battery. Notice that it's about a $33,000 car. This car I chose deliberately because I wanted to work with a plug-in hybrid. This is the only car of its type that was available not only in the state of Florida, but the entire Southern District of Toyota. So the push behind these cars from Toyota seemed to be almost non-existent. But what have I got? It's larger than the hybrid battery. They claim it has a range of 24 miles. My experience is I get 35 to 36 miles on a charge. But more importantly, it is a small, highly efficient gas engine. If I'm just running on gas at 75 miles an hour, I get 52 miles a gallon. Not at all bad. So it gives me a total range of 500 miles for the gas, plus another 35 miles for the electric, or as they quote in the advertising, total range, about 540 miles. No range anxiety because gas is readily available. And I generally charge the battery overnight by plugging it in when I get home, and it's fully charged in the morning. To be more precise, I set it so that it charges at 8 o'clock in the morning because the solar panels, which should be referred to on my roof, are not running my air conditioning or my heating at that hour, so I can dump directly from the solar panels into the car. It's a little cheaper to use it myself than to sell it to the utility. So basically, cost per mile is 2 cents in electric mode, 6 cents in gasoline mode at $3 a gallon, and at 12 cents per kilowatt hour. Currently, I have 12,000 plus miles on the car. I've had it 2 years. I have used 29.5 gallons of gas. My net gas mileage on the car is 416 miles per gallon, which I consider fairly green. And if everybody was doing that, we'd probably make a big step toward getting rid of the carbon issue. However, all the buzz is, of course, oh no, let me show this. This is my dashboard display. A couple points of interest. One, the air conditioning is a significant effect. You can get up to 15 to 20% of your energy usage just running your air conditioning. Also notice that my gas tank is almost full, and it has remained that way ever since COVID struck. Now, of course, there's the Tesla. This is one of 3 models that are on the road now. Notice the price is a little bit higher. I'll show prices for the other models later in the presentation. I could not justify buying such a vehicle at the present time. I'm glad I didn't. This vehicle gets 3 or 4 miles per kilowatt hour. These are important numbers to remember. Miles per kilowatt hour. That's what was on the dashboard display I just showed. That costs about 3 cents per mile if you charge it at home. The mileage goes down as the vehicle size goes up, of course, and the battery is large enough to be used exclusively. And in fact, it must be used exclusively because there is no other option. If you're out of battery, you stop. So therefore, you must find a charging station for a longer trip. Now, longer trip is somewhere around 300 miles. My standard trip, if I'm doing a long trip, is 500 miles per day. That implies I have to charge once in the middle of the day and once at the end of the day. And I personally find that somewhat of a pain. So I don't do it. All right, shifting gears, second item on the agenda, chargers. Chargers come in 3 flavors. The level 1 charger is very simple. You take the cord from the car and plug it into the 120 volt outlet. What do you get? 15 amps, 120 volts, 1.8 kilowatts per hour, and that's a 9-mile range for every hour. Now that's not very much until you realize that overnight you've got 10 hours. That's a 90-mile range, and the most I can get is about 36. So I could do quite well by just plugging into a 120 volt outlet. No rewiring. So this is adequate for the current PHEV, plug-in hybrid electric vehicle. The maximum battery size is approaching 50 miles at this point, as we'll see from a table later on. And these outlets are ubiquitous. You know, any garage is going to have an outlet. so you're all ready to go as soon as you bring the vehicle home. However, you can go a little higher if you want to, or feel you need to. Level 2 chargers. This is the bulk of it. This requires a 220 volt, 40 amp outlet, which is similar to an electric dryer outlet. The lower level car, mine's a 2A. I can only draw 15 amps out of this because that's the way the town is set up. However, that gives me 18-mile range per charging hour, which means it needs a maximum of 2 hours. Or for a 10-hour period, I can get 180 miles, but of course I can't because my battery won't support that. It costs about $400 for the charger and maybe $500 installation costs, unless you're do-it-yourselfer like I am, and I just put it in an afternoon, running it from the breaker box out to where the car is. However, the level 2 has an upper level as well. This draws the full 40 amps at 240 volts. That gives you 9.5 kilowatts per hour, or 47.5 mile range each hour. So if I left it plugged in the full 10-hour nighttime, I could get 475 miles out of my level 2 charger, which is more than any battery available on them. So that means you need a special transformer. So these are only available in public locations, generally near the interstate highways. And they're essential if you're going to do a long trip in an EV, because remember, you can't in the EV switch to gas if you run out of electricity. You have to find a charging station. These are not required for the plug-in hybrids because you can switch fuels, and in fact, few public plug-in hybrids have the high charge rate. In fact, only the Highlander is the only one I found that does allow the high charging rate. Now, there's a problem, as there often is. We haven't got compatibility. There's 3 different charger plug types, and somebody in the standards area has to knock some heads together to get this done. My hope is at least you have a conversion cable available. Tax is a problem because highways are supported by gasoline taxes. Federal 18.3 cents per gallon, states anywhere from 20 cents to more than 50 cents a gallon. And with an electric vehicle, no gas, no highway tax. Now, this is a plus until you realize that this will not last because we still have to maintain the highways. So somebody's going to pay. And it was rather annoying when early on I learned that some states are charging extra for the license fee for electric vehicles, figuring that's not a very good way of encouraging electric vehicles. But it's something we have to get it taken care of because an electric fleet is not sustainable in the highway tax area. So how that works out remains to be seen. A good perk is access to the high occupancy vehicles lanes. Some states allow that, and it's certainly more attractive than putting a dummy in the passenger seat. But again, not sustainable for an all-electric fleet. So. And here's one I just added. The interstate highway was sort of a disaster for downtowns because everybody went around the town and nobody went downtown. Now, does the same thing happen with charging stations? Are charging stations sparse? And I can't go to interesting areas like national parks, which are hours in the company parking lot. In fact, you could probably get away with a level 1 or level 2A. Probably level 2 would be the preferred mode, but 2A would certainly be sufficient. Want to do charging is the hotels or any other place where the car is going to be sitting at night. Because here's another 10-hour time slice where we can use a relatively low charging rate and still achieve what we need to achieve. A daily commuter lot, the car would be there all day, and if we had level 1 chargers at each slot, the car would be fully charged at the end of the day, assuming a 40 or 50 mile range battery. Now EV and PHEV to plug in for the duration of the stay, and since it's a level 1, the EV is not having a, and the hotels, of course, can do the same thing. In restaurants, same problems, not enough time, too cyclic. We need a charger reservation system for the public chargers. You need a vehicle or phone app software that monitors the car position, monitors the battery charge, locates chargers along the route, presents the driver with charger options, wait time, location, price. The driver selects the option, or the software does. It reserves the charger for time of arrival and amount of charge required, provides payment information, and pays the reservation deposit. You better pay